We're going to learn about mole, how to calculate a certain number of atoms or molecules is equivalent to how many moles, and learn about molar mass. So mole is a concept that many of you are in love with it.
No, I'm not.
Obviously, the first question that comes to mind is that who for the first time came up with this concept? And the answer is this guy, Avogadro. He proposed, let's torture our youth with this made-up concept, and of course he was doomed at the end of his life by many moles on his face, and he died as a big giant mole. I'm just joking.
Very funny.
None of that is true, but he did come up with the concept of mole, and we're going to learn how mole is defined. So, you know the word dozen? What does it mean, dozen? It's coming from Latin. Even today, Spanish, they say doce means 12. So this is a counting unit. When you say, I had dozen of ice creams today, that means you're going to feel sick soon. But that also means you had 12 ice creams today. So dozen means 12 of something. A dozen apple means 12 apples. A dozen oranges, that means 12 oranges. And so on. Mole as well is a counting unit, and 1 mole of something is equivalent to a big number, a huge number, 6.02 roughly speaking, times 10 to the power of 23. You see, this is a big number. That is like almost 6 with 23 zeros in front of it. To just give you a perspective, today on planet Earth, far less than 10 billion people live. 10 billion. So billion is also, you can consider it a counting unit. And is equivalent to, when you say billion, that's, we know million has 6 zeros. Billion has 9 zeros. So 10 billion, that's 10 times 10 to the power of 9. That equals 10 to the power of 10. So less than 10 to the power of 10 people live on Earth today, and mole is way larger than that. So we have way less than 1 mole of people on planet. So such a huge counting unit, what is it good for? It's good for counting small stuff like atoms and molecules. And the reason it was invented was that atoms and molecules are so small, they're difficult to weigh them in the lab. So if you want to weigh 1 atom in the lab, that's almost impossible. So they decided on a big number, and in another video we're going to say why specifically this number, and why not just, let's say, 1 billion atoms. Why not say 10 to the power of 23? Why 6.02 times 10 to the power of 23? That's going to be a subject for another video. The function of mole is that we decide on a huge number, so we say this number of atoms or molecules, and then we can have, at least we can see them, we can carry them and put them on a scale and find out how many grams they weigh and so on. So let's see an example to understand the concept of mole better. Let's say you are asked how many moles there are. So how many moles there are in 12.04 times 10 to the power of 3 atoms of carbon. It's equivalent to how many moles? We're going to convert the number of atoms into moles of carbon. So we need a conversion fraction. So we know that on our conversion reaction, on the top it has to be moles. So we have to find out moles of carbon. So I put that on the top. And at the bottom has to be what I'm getting rid of. So that's atoms of carbon. The number of atoms of carbon. So now I have to put some numbers into my conversion fraction or conversion ratio. What's the number here? We have to put numbers that are equivalent so that they make this conversion reaction equivalent, the top and bottom. So we know 1 mole of anything is 6.02 times 10 to the power of 23 atoms or number of that things. So that is our conversion reaction. Basically, we just need to say 12.04 times 10 to the power of 23 divided by 6.02 times 10 to the power of 23. You realize that you do the division, 10 to the power of 23 cancels from top and bottom. 12.04 over 6.02. You can perform that either with your calculators or just in your head, and you realize the answer is 2. So the answer is 2 moles of carbon. So that many atoms of carbon is equivalent to just 2 moles of carbon. Now let's learn about the concept of molar mass. And that's referring to how much does 1 mole of something weighs. The mass of 1 mole of something, that's called molar mass. And of course it will be different for every element or every compound, because atoms of different elements are made up of different number of protons and neutrons. For example, carbon, in its nucleus, it has 6 protons, and oxygen has 8 protons. And of course, different isotopes of them, they have different number of neutrons. Some of them, for example, for oxygen, some of them have 8 neutrons, so in total mass number will be 16. And carbon, some isotopes of carbon have 12 as the mass number, so meaning 6 neutrons as well. So now oxygen, 1 atom of oxygen, you know it's heavier than 1 atom of carbon because its nucleus has more stuff in it. Therefore, 2 atoms of oxygen is heavier than 2 atoms of carbon. And similarly, 6.02 times 10 to the power of 23 atoms of oxygen is heavier than same number of atoms of carbon. This is heavier because oxygen atoms is heavier than carbon atoms. Therefore, we expect that 1 mole of oxygen is heavier than 1 mole of carbon. And in fact, people have measured the weight of 1 mole of oxygen, 1 mole of carbon, and all the elements. So that information is mentioned on the periodic table. For example, for carbon, the molar mass of carbon is roughly 12 grams per mole. Or to be more precise, 12.011 gram per mole. That's the molar mass of carbon. What does that mean, gram per mole? That means 1 mole of carbon is equivalent to 12.011 grams of carbon. So grams per mole. Per here means divided. So for that means 1 mole here in the denominator. You can write grams per mole also like this. Grams per mole. So that means here 1. And on the top you have 12.011 gram. That's the definition of molar mass. And for every element is different. For example, for oxygen is roughly 16, but to be more precise, 15.999 grams per mole. So you see now, dealing with 1 mole of carbon is easier than dealing with just atoms of carbon that they're so small. So now with 12 grams you can handle it in the laboratory, you can weigh it on a scale. That's why the concept of mole exists. The word mole means, coming from Latin, and means a small mass. It has the same root as the word molecule. Okay, mole, mass, molecule, these have the same roots. Let's see an example about molar mass. Suppose you're asked how much 2 moles of carbon weighs. How much 2 moles of carbon weighs, like how many grams there are if you have 2 moles of carbon. So you have to use the information from periodic table about the molar mass of carbon. Let's say you read from the periodic table that the molar mass of carbon is 12.011 gram per mole. So you're given that information already, either in the question you're given or you're referred to a periodic table. So having that, now we can find how many grams there are in 2 moles of carbon. Let's see. 2 moles of carbon we want to convert it into how many grams of carbon. We need a conversion fraction. So in the bottom, we need to get rid of mole of carbon. So I put mole of carbon at the bottom. And at the top, we need to have in the result grams of carbon. So I put grams of carbon. Nice. The units now are all set. Now we need to complete our fraction, our conversion fraction, by putting numbers into it. So I know the easiest way is to say just 1 mole of carbon is how many grams. Using the molar mass information, I know 1 mole of carbon is equivalent to 12.011 grams of carbon. So that's it. That's my conversion fraction right there. So I have to multiply 2 by 12.011, which equals, doing the multiplication, 24.022 grams of carbon. That's the answer. So with conversion fractions, it makes it much less probable to make a mistake. Let's see another example. This time, instead of just having a pure element like carbon, let's talk about compounds. For example, table salt, something that you can find at home. It's made up of 2 elements, sodium, chloride. Sodium and chlorine, they combine together and we call it sodium chloride. Now, suppose you are asked 3 moles of sodium chloride is equivalent to how many grams? How much does it weigh? How do you find it? First step is to find the molar mass of sodium chloride. Molar mass of sodium chloride. So we refer to the periodic table. But on the periodic table, you don't find any compound. It's just all the elements are listed there. So we need to individually find the molar mass of sodium and also the molar mass of chlorine, and then add them together. In that way, you find the molar mass of this molecule, NaCl. So if you look at the periodic table for sodium, you will find its molar mass is almost 23 grams per mole. Sometimes it's listed as 22.99, but we would say roughly 23. It's okay. And then chlorine, you will see it's 35.45 grams per mole. Nice. With that information, now I can add them together. In the molecule of NaCl, I have 1 sodium and 1 chloride. So I add 123 plus, and then another 35.45. And the result is 58.45 grams per mole. So that's the molar mass of this molecule, table salt, or NaCl, sodium chloride. With that information available, now we can answer the question. 3 moles of NaCl needs to be converted to grams of NaCl. How many grams of NaCl? So again, conversion rates, conversion fractions. At the bottom, I put what the unit that I want to eliminate. I want to eliminate moles. So moles of NaCl is at the bottom. On the top, the unit that I want to convert it to, I want to have at the end grams of NaCl. Okay, now I fill up the numbers. So what numbers works here? 1 mole of NaCl from the molar mass. We know that 1 mole of NaCl, that is 6.02 times 10 to the power of 23 molecules of NaCl. How much do they weigh? 58.45 grams of NaCl. So we have our conversion rate. You just multiply 3 by 58.45 and you have your answer. So I got 175.35 grams That's the final answer. 3 moles of NaCl weighs 175.35 grams of NaCl. Hope you guys enjoyed it. Let me know if you have any questions. Thanks for watching.